We are doing the complex numbers and quadratic equation. In this, we will do today the modulus of complex number a plus iota b. How we can find the modulus of a plus iota b? Look here, if this we write as a z is a plus iota b, and modulus we will represent by this type modulus of z, and this will be equal to root of a square plus b square, and this we can write by r also. R here, this the modulus we represent by r also. A question is given, find the modulus of 2 minus 5 iota. This we write by the modulus of z, and this will be equal to 2 look here, this we write 2 square and plus minus 5 whole square, and this will be equal to 2 square is 4, 5 square is 25, so this modulus will be root 29. This is our answer. Now we have to find the conjugate of a complex number z equal to a plus iota b. Look here, conjugate of this will be represented by z bar, and this is equal to a minus iota b. Okay, if here is given plus iota, we write here minus iota are given, and we have to find the conjugate of these numbers. Look here, z1 is 3 plus iota. We have to find the conjugate, and conjugate of z1 we represent by z1 bar, and this will be equal to this plus iota, so we write here minus iota. Okay, and z2 conjugate will be equal to, look at 2 minus 7 iota, this minus we have to make in plus, so we write here 2 plus 7 iota, and conjugate of this third z3 bar equal to minus 5 and plus 6 iota. Okay, and z4 bar will be equal to minus 4 minus 7 iota. So this type we can find the conjugate. Here some properties of conjugate and modulus. So look at z1 and z2, and we have modulus, then this will be equal to z1 modulus into z2 modulus. Okay, this is the first property. Second property we have, this is the, if we have the divide, z1 is divided by z2, and this will be equal to modulus of z1 upon modulus of z2. Third property is for the conjugate, and look here, we have if z1 z2 whole and conjugate, this will be equal to z1 conjugate into z2 conjugate. And if we have this fourth properties here, z1 plus minus z2 and whole and conjugate, this will be equal to z1 conjugate plus minus z2 conjugate. Fifth property is, if z1 upon z2 and whole and conjugate, this will be equal to z1 conjugate upon z2 conjugate. All of you understand this? So these properties you have to understand. One more property, sixth property, is z into z conjugate. Z into Z conjugate equal to modulus Z and whole square. Okay, look here, if we have to find Z inverse, how we can find? Look here, this Z is given A plus iota B, and we have to find inverse of this. This will be equal to 1 upon, we can write A plus iota B, and we multiply by a minus iota b and divide by a minus iota b. We will get here a minus iota b upon a square plus b square. And look here, what is this? This is the z conjugate, and this is equal to modulus of z. So we can write here that z inverse is equal to z conjugate upon modulus z square. This is square will be, this is modulus z square. So this formula is we can use to find the inverse of any complex number. If x minus iota y equal to root of a minus iota b upon c minus iota d, then we have to prove x square plus y square and whole square equal to a square plus b square upon c square plus d square. Look here, for these, here given x minus iota y equal to root of a minus iota b upon c minus iota d. This is equation 1, and we write the conjugate of this, conjugate of equation 1. So for the conjugate, what we write, look here, x plus iota y. Wherever you have the iota, there you write minus iota, then plus iota, then minus iota. So here also you do the same work. A, here minus iota means we can write plus iota b upon, here also you can use c minus will be plus iota d. This is 2, and now we will multiply 1 and 2, multiply 1 and 2. So what we get to get, x minus iota y into x plus iota y equal to root a minus iota b upon c minus iota d into, we can write a plus iota b upon c plus iota d. So what we get here, this is first square is x square minus iota y whole square, and this will be equal to root of a square minus iota b whole square upon c whole square minus iota d whole square. Okay, this will be equal to x square, iota square is minus, and minus plus y square, and this we can write root of a square plus b square upon c square plus d square. Now we do square both side, square both side. When we do square both side, we will get here x square plus y square and whole square, and this is equal to a square plus b square upon c square plus d square. This only we have to prove, so you can write hence prove. We have to find the modulus of 1 plus iota upon 1 minus iota and minus 1 minus iota upon 1 plus iota. So for this, first of all we can use the brackets, okay, and now you will take the LCM. Here LCM is 1 minus iota into 1 plus iota. Look here, this is we can have here 1 minus iota, so we have to multiply by 1 plus iota. So 1 plus iota into 1 plus iota is 1 plus iota whole square. Here 1 minus iota we have to multiply by 1 minus iota, so this will be whole square. Now we open the bracket, we get 1 plus 2 iota plus iota square minus, here also we get 1 minus 2 iota plus iota whole square upon, we get here 1 whole square minus iota whole square. So look here, when we open the bracket, 1 plus 2 iota minus 1 and minus, and we have here 1 minus 2 iota and minus 1 upon, this is 1 square is 1 and minus 1. This we can write, this is cancel, this also cancel, and minus plus 2 iota and 2 iota is 4 iota upon, we get 2. So this will be 2 iota, okay, and this 2 iota we have to find the modulus. So we can write modulus of 0 plus 2 iota equal to root of 0 square plus 2 square, so this will be 2. So modulus we get here 2. This we can write as a 0 plus 2 iota. Now modulus of 0 plus 2 iota equal to root of 0 square plus 2 square is 2, so modulus is 2. Argand plane complex number x plus iota y which correspond to ordered pair xy bracket can be represented geometrically as unique point pxy in the xy plane. The plane having a complex number is called complex plane or argand plane. So argand plane means we represent the complex number on a graph. Represent complex numbers on argand plane. Here first point is 3 plus 5 iota. Second point is minus 2 plus 3 iota. Third point is minus 7 minus 3 iota. Fourth point is 0 plus 2 iota. Fifth point is 2 plus 0 iota. Sixth point is 3 minus 4 iota. Seventh point is 0 minus 3 iota. Eighth point is minus 2 plus 0 iota. First point we have to mark here. So 3 axis, look here, real part we will put on an x-axis and imaginary part we put on y-axis. So 3 was x-axis. Okay, this is 3 on x-axis, and on y-axis we will put 5. So 4 is here, 5. So 3 and 5. This point is here. This point is 3 plus 5 iota. All of you understand? Next is minus 2 plus 3 iota. Minus 2 on x-axis, minus 2. Minus 2 is here, and y is 3. 1, 2, 3. So this point is here is minus 2 plus 3 iota. Okay, and look here, this point minus 7 minus 3 iota, x equal to minus 7 and y equal to minus 3. So minus 3 is here, this point. Okay, this point we write as a minus 7 and minus 3 iota. Look here, 0 plus 2 iota. 0, x is 0 and y is 2. 2 iota means this point 2 is here. So this point we can write 0 plus 2 iota. Next is 2 plus 0 iota means this point 2 and y is 0. So this point is 2 plus 0 iota. All of you understand? Next is 3 minus 4 iota. 3 minus 4 iota, x is 3 and y is minus 4. X is 3, y is minus 4. 1, 2, 3, 4. This will be, this point is 3 minus 4 iota. Will you understand this point? This point is 3 minus 4 iota. 0 minus 3 iota, 0 here and minus 3. This point is 0 minus 3 iota. This is minus 2 plus 0 iota, minus 2. This is minus 2. This is minus 2, and this point is minus 2 plus 0 iota. All of you understand these points very good. Look here, if this is a argand plane, and on this argand plane one point is here, this point we can take, and this point is we can write x and y, or in a complex form we can write x plus iota y minus iota y, x minus iota x minus iota y. Okay, and here we can see, look here, this is what is, if this point is z, then this point is a z bar. Look here, we can say this is an image in the x-axis. This is a image in axis, and this is the conjugate. This is the conjugate also. Okay, so here this is the image in the x-axis. This point we can write x minus y, and geometrically x minus y is the mirror image of the point xy, on the real axis. A point xy is given and we have to check this mirror image.